So Charles, are you going to be, are you ready?
Yep, I am ready.
You're going to be doing a slide presentation. I'm sure we're going to learn something here. You're a disruptor. You're in a way the scourge of the record cleaning industry because you're doing new things and you're discovering new things. And some people with the older technology or with different technology don't necessarily agree with them, but we're going to listen to you and make our own judgments. So take it away, Charles. Thank you for doing this.
Well, first of all, I'd like to thank everyone and especially the other audio societies such as the LA Society that have also blasted your little blurb on the seminar. What I'm going to try to do today is, not knowing the full background of the complete audience, we're going to cover record production. We're going to cover cleaning solvents, cleaning solutions. We're going to delve into how these all apply to cleaning records, how they apply to what I call record restoration. But I'm going to try to keep it generic so that we all pick up a couple of things that we really didn't understand. And that then allows you as a consumer to then, when a technology comes out to do something to a record, you're able to then decide whether that technology is worth it or whether it isn't, whether it's going to damage records, is it just snake oil? And yes, I certainly have been disruptive. I have been helping J.R. Boisclair, who resurrected the Wally Tools family of products to, again, record production, record quality, record recording, how to play it back from stylus to cartridge to phono stage. Those are all very important aspects for us to reproduce sound. So we're going to be talking about record production, and then you can figure out how your needle is touching the record and what we're trying to do by taking a look at the various cleaning processes and seeing whether they're actually doing something or not. And again, to prove what we've done, Michael Fremer cost me $170,000 to buy a Keyence VX-7000. The lens alone is $72,000. And it allows me to go into the grooves and do 2 and 3D imaging right into the groove and see what's happening. And before me buying that, Michael was very skeptical, as everyone else, about what we are talking about. I have some tips on how you can actually see, at least on the ultrasonic side, whether an ultrasonic is actually doing anything and whether it is an ultrasonic. So for no adu, I've divided this into 4 sections. We're going to talk about how records are made. We're going to talk about cleaning and chemicals and how they affect records and playback and the health of records and your health. We're going to talk about my disruptive technologies on understanding and taking a look at records first from a collector's standpoint, and then from someone that wants to conserve them and record them for eternity on digital, and obviously the question and answer. And I really want to stress that this isn't a monologue. I'm trying to give you some information that's background information. It's generic, it's scientific. I have a whole list of references that I can give you after that you can go and hit all of these websites. They're from physicists, scientists, associations, the RIAA, and so on. So what is being presented here isn't something according to Kirmuss, except for the testing using, as you'll see later, aluminum foil in various ultrasonics to see whether they perform or not, and whether my theories of, as you'll see, are valid or not. So first of all, let's take a look at how records are made. In June of 2018, I was part of the American Society of Record Collections annual trade show seminar out in Portland. And we all had the chance to visit the Cascade record pressing factory. And if you take a look, this is off the web here, where you'll go from left to right, then right to left, then left to right. There's a whole process of how we produce basically the lacquer, the recording master, and then we go down into how records are actually made. I'm going to not talk about the capture of the analog signal going into the lacquer cutting process and how the plating is done. These are available, and you can see that as we go down, the grooves are reversed and so on. We're not going to talk about that. We're actually going to talk about us creating a record from the PVC pellets on the way down. Now, at Cascade, you'll see some equipment that's very vintage. Here's a Hamilton record molding automation system that was made in the 50s. What you'll see is very generic as how pressing plants actually change the PVC into a final product. At the Making Vinyl Hollywood show in 2018, Harm Thionès from Syncom in in Europe, I should say, is now creating a method where we no longer use biscuits or PVC pellets. And instead of doing a stamping going down of a biscuit, we're now actually having the stampers horizontally and injecting liquid PVC that is not PVC, it's not a petroleum product, and the record pops out like normal, but it only takes 30 seconds instead of 30 minutes. And he was actually playing back records at the trade show, the Hollywood Vinyl Making Vinyl session. And they also use the famous release agent that we also removed. So what I'm describing here will also work with the new generation of techniques of making records as we move forward away from PVC plastic per se. They are using a green material, soybeans or whatever. So this is one of many machines that they have over at Cascade. If you take a look at the right-hand side where my little hand is going up and down, we have a hopper, and that hopper has pellets inside. And then there is a tube that goes down and creates the biscuit in a little press. And then here in this area where I'm circling, we actually have the stamper that stamps the record, and then it pops out and records are stacked on this area here. So step one, PVC pellets are dropped into a hopper. This is a very famous, the best PVC is made out in Taiwan. And to the pellet mix, we add stabilizer, plasticizers, and liquefiers that end up in a hopper up here. That's the kind of the diagram, and this is the actual picture of the hopper. So that mix is in here. Different plants use different mixes, and we add stabilizers and more plasticizers and liquefiers in the mix, because when we take a record, and if the record isn't pressed properly, it is chopped up with label and ink and all, and is put back into the hopper. So we need to change the mix, and you'll see what happens when we don't have a right mix. So we can add colors. These are, again, colors added to the PVC. And typically PVC actually is clear, but we use carbon to make it black. And in this case here, you see on the right-hand side where they actually, before having the press come down, put red pellets on the biscuit, and then the pressing came out with this funky design here on the right. And you can see this is a record that has come out of the press that has not been trimmed. So that's why you see these edges. So here's the hopper. The pellets go down a screw conveyor, and they are heated. And when they're heated, they are molded into a biscuit. The Canadians, for the guys like Paul Trepanier, who's online here, bonjour, Paul. This is a hockey puck that we use in Quebec here for the kids playing hockey. No, a little humor. So that's what a biscuit looks like. This one's a little deformed. Here's a formed biscuit right here. So what happens in the machine is this is the bottom stamper, side B. So this is basically a stamper made off the master. A label falls down onto the stamper, and then this hot biscuit is now placed onto the stamper, the label with face down, and then the label comes down onto the biscuit face up. So this is now ready for the press. Up top here, we have stamper side A. So with this in position, we now have the press come down, and it basically applies pressure onto a hot biscuit. The pressure itself increases the temperature of the plastic, the PVC mix and so on, by 100 degrees Celsius. So applying pressure increases the heat, and you can see now the biscuit being squeezed into the shape of a record. So the excess plastic gets squeezed out. And here's a view now where once this is being pressed, pressure is released so that we cool down the now pressed record by about 80 degrees Celsius before this opens up. And at the same time, the record now starts to spin, where we have a cutting edge here that will now cut and remove the excess plastic. So now this is spinning, the plastic is cut, and basically it moves. You can see now the top section moves the record over and drops it on this spindle here, as you see on the left. And as these records come out every 3 or 4 minutes, there is a paper positioned onto the previous record that then allows each record to cool down individually, but in unison. So obviously what I mentioned, the temperatures that I listed are a bit different depending on the machines, but basically the biscuit is preheated, pressure is applied, the heat goes up. We now bring the record down to whatever thickness that we wanted, whether it's going to be a 180 gram record, 220, 200, or whatever. The pressure, when it's removed, the mold, as I call it, the record cools down, and then it opens up. And then obviously we need this cooling process, because if you take a very hot record and you dump it out, you'll get a warp. So some people are saying, why am I getting brand new records that are warped? It's because in the process, they were making more records more rapidly, and they were not allowing the records to cool down. So that's one of the reasons why we have records that are warped. And more, I receive calls from people saying, I have a warped record. And I thought, well, let's see, where did you buy it? Did it ended up in a UPS truck going ground and it's in the back and very hot? Because as you know, if you take a record and you put it on the back seat of your car, and depending on the temperature inside, in Arizona, you'll see temperature of about 142 degrees Fahrenheit in a closed car. Obviously, temperatures are much higher. But I said, well, it has to be something in transport. No, it's because we didn't let the records cool enough before they were popped out. So here we are. This is again, the ASRC group. And here's the famous biscuit that they've made. Here is a pressing of a record that came out. You can see the label on the record, so it's not glued onto the record. It actually is part and part of the pressing, but this was taken out of the press before trimming. So we speed it up and accelerate it a bit. That's why you see, this edge here, we got it cut, and then we stopped the cutting process. So something to note, we do have, and I'm not going to talk about lacquered records. That's another session that we can put on. And I'm not going to talk about Edison cylinders, which we now restore for the first time in 45 years. We made a presentation to the ARSC back in autumn time last year, where we now have a process to restore them. using the same machine. But polystyrene records were made a bit differently, where they've added wax inside and zinc so that the styluses do not eat the polystyrene. And for those of us that are old enough, we had the energy crisis back in the 70s, early 80s, and we saw a lot of polystyrene records come out. Number one, the temperatures are much lower. They're much more fragile, but at the same time, they also do not sound as good as PVC. And from the 40s going to the 70s, when we were now saying, let's use polystyrene rather the pure PVC, they've had to also concoct various mixes and primarily wax, so that the records that are flimsy are actually can withstand the dyne, the pressure of the needle, and not destroying the needle after 50 plays, or sorry, destroying the grooves after 50 plays. So here again, we see a variety of labels that are all pre-printed. These obviously are put into a dehumidifier to dehumidify the labels to a certain percentage, and then they end up obviously on the biscuit and then are pressed and become part and parcel of the record. So one of the many disruptions is my terminology of a release agent. I remember, I'm an audiophile like you. I worked in Montreal at the audio shop at Bill Layton Audio back in the 70s when I was in high school. That's where I inherited, didn't buy, I inherited all the Macintosh equipment that I have, my Dragon cassette deck, my Akai 747, my parastatic felt disc preener from Dr. Watts in England in the 70s. But this release agent is in fact there. Maybe some science to it. Why does the record pop out easily from the stamper? Well, when I came on the scene just as an audiophile and kind of a kid that said, how come there are $10,000 and $8,000 ultrasonic machines? How come they're $4,000, $5,000, $20,000 vacuum machines? There was something, you know, I couldn't understand it. I use ultrasonics in my own factory for homeland security, and I just couldn't figure out the costs. And when I started to meet, or the first time I met Mike Fremer, he says, you're full of it. When I go to a record pressing plant, I don't see someone spraying PAM on the stamper. I said, yes, it's part and parcel of the stabilizer, liquefier, plasticizer mix. So we used the scientific method to figure this out. So what we did is, on the left-hand side is the Keyence VX-7000. And that, again, that's a $70,000 lens. The light goes through the lens, so there is no lighting on the record by external sources. The light goes through the lens via fiber optic, and inside there's a digital CMOS sensor. And in order for me to take 3D measurements, which I do, we set this at 0, and when I press capture, this whole assembly moves on a motor upwards and takes a 0.1 micron increase in height. And it takes 1,000 snapshots, and it takes about 5 to 10 minutes to process the images in a 3D. So this is basically where I can take a look inside a groove and measure it. This isn't a USB camera with lights and whatever, and you'll see on the website people taking pictures of this is what a groove looks like. We're looking right inside the groove, and by doing this, we can measure it. Going back in slides that I prepared is in the 60s and 70s, Shure came out with the V15 cartridge, or cartridge needle assembly. And they discovered in their design, elliptical design, brand new angle cuts and whatever in the V15, Mark I, Mark II, Mark III, and so on, that they now started to look inside the groove. And of course, in those days, you could go electron microscope at audio stores like Ultrasonic in Montreal. Paul's online here. I remember they had the Shure microscope where they looked at, you know, the needle. Well, I can measure everything. And when Shure was developing this, they noticed that there were thicknesses that varied between the various records. And they discovered a pressing oil. So They called it a pressing oil, and it got lost in the 70s. I call it a release agent. So in the short discovery, this now kind of leads into away from the processing of records, that it goes into now taking a look at their discovery, where they were saying, well, you know, here's our stylus tip, the V15, type 4, type 3, the angles and so on. And J.R. Boisclair from Wally Tools is a great expert now on that, as disruptive, perhaps more disruptive than me. But sure discovered that we have, geez, we got this pressing layer, this pressing oil. And this is depicted in their sketch that they produced in number 1. Number 2, they say we have collected dust and debris that gets onto the record. And then here we're trying to wipe this down in number 3. And well, here we're using, well, we're cleaning it with the liquid enhancers and enzymes and whatever. And you see that, well, you know, we really haven't removed much from the original. And then here, cleaned with liquid containing alcohol. Ooh, well, you see that's a little, it hasn't done much either. And then now here we're using another cleaning agent, where after using it, we actually coat the record. So we have a pressing oil that's coating the detail. And then in the various different technologies or mechanical concepts that we have of cleaning records, we're not actually removing this thin layer of pressing oil. Needless to say, as our discovery you'll see later, where when records come out of the press, they also collect and micro-weld debris, or primarily dust, into the release agent, which also then becomes a problem. So here at Cascadia, one of the interesting things was where when they take records that are pressed that are defective, in their sense, it wasn't cut right. Forget about them inspecting the record before packaging, where they play the record back in a technical area. They have situations where they get records that do not pop out of the stamper, because they have recycled records that have labels printed. So when you now chop that up and put it back into the hopper with PVC, it's no longer pure PVC. So now we're getting a different issue, where the temperature coefficient of having the stamper come out sees, in fact, the record gets stuck into the stamper. So here you can see the stamper, side B is right here. Side A has come up on the top. There's a biscuit that they have over here. And here's a record where it has not come out. And lo and behold, this is where a mix comes in, where they have to modify their mix. Unfortunately, they already have biscuits that have already gone through from the hopper through the little press that made the biscuit and are in a stack ready to drop down. Well, to kind of get them unstuck, this is what they use. They use metal gloss polish used on automotive wheels and polished the stamper in order for the next 4 or 3 records not to get jammed and perhaps damage the stamper by having to be peeled off. So this kind of is a release agent, not found at your home where you're playing your music, but at the factory floor itself. And you can see the gobs of it over here. So they have been using it. And that was their method of getting the record that didn't have the right mix, because now we've put in recycled chopped up records with the label and ink all in there to kind of get to the right mix. So the mix, timing, and pressure were their solution, but it goes back to where we have a release agent. So being disruptive again, why do we hear pops in newly pressed records that just come out of the package? I remember I'm a 70s kid in high school, and I loved disco music. I went to Heathkit down the street. I built amplifiers, speakers, tube stuff, whatever. And I liked the boom, 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 but I hated the pop, pop, pop. So in those days, we had Lafayette Electronics, we had Radio Shack, we had Thorens. They sold sprays and you put them on the records so you don't hear the pops. Well, you weren't doing any cleaning, you were coating the records, where the needle now was riding higher, so I wasn't hitting that pop. But at the factory, these areas are all very dirty. So our analysis is we have a hot record that comes out of the press. All factories that I've seen, and I haven't seen many of them, Mike Fremer has seen a lot more, but they're not necessarily the cleanest. There's a video somewhere in the Bronx, Jamaica Rail or something, the surface subway, when it goes over, it's actually on top of a pressing company. And you actually see the dust falling down in the video they made on how records are made. So we have dusty areas in the factory. And obviously, the dust lands onto the record and the record is warm. So here is, using our microscopy here, here we have a record groove, and you can see this material over here, 1, 2, 3, 4, 5, 6. We have 6 dust particles that have been micro-welded into the record. What does that mean? When I play this record 3 times, and we have video of that, the dust is always in the same area and has not been removed by the needle because it's in the hot release agent and it's sitting in there. It's glued in there. And it gets glued in just because it's around the hot record, but also as records drop, you also saw the papers that are there. The papers aren't very clean. They have fibers and whatever. So the record drops on the paper. Another paper is put onto the record. Another record, hot record, drops onto the paper, and we keep on going. And in this case, at the factory, it was cherry blossom time out in Portland, and we had the overhead doors open and having all this pollen come in. So this on the left-hand side is the dust, and on the right-hand side, this is, dust gone, release agent gone. Now, how do I know there's a release agent? Well, this system, the microscope here, I've gone from 31.83 microns from bottom of groove to top to 30.94 microns on the left-hand side, on the right-hand side here, that I've removed the release agent after using a process. And that's where, if I can measure it, I know it's there. And this goes back into the debate that we've all had where people are being buying protectants. There's a picture on one of Mike Weber's Analog Planets where they're feeding a facsimile of Sal with a bottle of some protectant coating stuff. If I can measure it and then process the record and remove it, if I can measure it, it is a coating. I've not molecularly changed plastic, and I certainly haven't made gold out of mercury and the like. So this is, if you take a look, this is what a pressing plant looks like. You know, it's not sterile. And here's the paper stackers and whatever. And we have stuff that falls on records. So what does dust look like? Well, before I even talk about that, if you play a brand new record, here's the other premise, that there is a release agent there. I hear a couple of pops. I'm going to play it later on tomorrow, next day. All of a sudden, there are more pops. Where do the pops come from? Well, as the record turns, the needle and the downward pressure, the dyne, and making contact with the groove creates heat. And that heat then warms up, not the plastic, not the PVC, not the polystyrene, the release agent. So now the release agent is warm, and dust around your turntable all of a sudden is landing onto the record, and it gets micro-welded again. So that's why it's very important. Forget about removing release agent. It's very important that you use 2 brushes before you play any record. First brush is a parastatic felt. I like the old disc preener that Dr. Watts made, which basically had, going back to Mr. Armstrong's question and also some points about some other people made, the patent that has expired from Dr. Watts in England had a 10 micron 10 micron diameter felt. If you take a look at the picture here, basically the bottom of the groove is about 6 microns in a curve. In the middle section, it's about 30, and then it's about 45 to 50, depending on the amplitude of the music, the wave changes. So we want to use a felt that's 10 micron in diameter to remove the dust. And then afterwards, we want to use a like-sized carbon fiber brush to remove the static. You do that before playing any record. I don't care about cleaning methods or whatever. As a matter of fact, probably the best records to buy are ones that are in estate sales or boot sales from homes of people that have passed away, or the grandkids or the kids don't want their parents' or grandparents' records. They haven't had the machines and whatever necessarily to clean them, so they're probably the best records. And just keep that dust away from your turntable. Use anti-static mats also, so it doesn't bring in dust. The question is always, what about an acrylic cover? Put it on your turntable. Why? We don't bring dust in. So these are all kind of some concepts and ideas that we've seen and we validated by the microscopy. So another myth. This is going to go into what's real and what isn't real on the internet. Here's pictures, that someone's posted on the internet. Here's a 150X record, blah, blah, blah. I see, some lines here. At 150X or 100X or 200X, let alone 400X, my measurements are here on the red. I should be able to see the details as cut by the cutter into the lathe into the lacquer into the master then into the stamper, and then the stamper into the PVC. I should see detail. What is this? Everyone's, this is where I don't like, we're not scientists. We love music. We love artists. We love emotion. But it shames me to see this. And here we have, someone posted 150X. Here's bacteria on a record. Well, bacteria at 150X doesn't look like that. And number two, bacteria is submicron. If we're dealing with the size of dust, going back to the left-hand side, dust and dirt is 3 to 5 microns in size. Bacteria is submicroscopic in size, or submicron, I should say. My needle is not bothered by bacteria. Colonoscopy equipment, those kind of things, very interested to get rid of bacteria off the camera that goes up your you-know-what for an inspection. That has nothing to do with record cleaning. So a lot of misinformation. Here you can see a magnification of 1,000. And again, we measure this. This is a $170,000 microscope. Alain from Montreal said, why don't you go to the office and show everyone a microscope? Well, I don't want to talk about the microscope. We can do that at another time, but it takes 5 minutes to process one of these images that you see on the left in 3D. But here are 1000X pictures of dust on records, and you can see the waves of the grooves, and I haven't gone into the groove yet to take a look at it at an angle of what we actually see, as you see here on the left-hand side here, where we actually see the minute detail. So here again, the dust is an enemy at the factory, and how do we remove that? I can certainly reduce the effect of me playing or creating more pops at the house by just making sure I don't have dust that falls onto the stylus, or sorry, the record that's spinning, that's being played by the stylus. To remove the factory pops, I need to go into the release agent. So here, again, this is over at Cascadia, and they play records after here's a Stanton turntable. They play records that come out of the machine, and they then try to find, if they have 4 pops or less, they'll accept it. And I was able to prove, let's play that record again. We had 3 pops. All of a sudden, 2 more were added. how come we have 6 pops now? Well, it's because we have a dusty area and we micro welded into the pressing oil, sure, Kirmuss release agent, the pops. Oh, that's nonsense. You're full of it, Charles. Well, you know, inside the car, I had my my restoration system. Didn't have access to distilled water, used regular water, put it in, processed the record, 4 or 5 minute cycles, and guess what? Not a single pop on that record that we all heard 4 pops and 6, or 3 and 6, or 3 plus 2 is 5. Sorry, can't even add anymore. So you can see also in their lab, they have pictures of anomalies in the stamper. They have issues of stitching. Again, the way that the stamper actually made the groove fill noise. You know, when you start, when you play a record, even, and this is something I learned from Mike Fremer, when the record is cut in between record tracks, if you wish, you know, we have a non-fill groove. There's no music, but we hear static and noise. We can't remove it, and in cases also, you hear on the last, on the first start between 2 record music pieces, you'll hear a background. You'll hear what sounds like a leftover from the song. It's because of the fact that we're playing one side. The left side of the needle is hitting the last track that had that wave. And then also now we're straight, which is the fill groove. Here's a bad stamper. So now this stamper now has to be changed. Something happened to it. So yes, there is a coating during the pressing process. No, it's not PAM. Records since the 2010s, we now have a situation again, since the broadcast went out by Mark for the session, lots of people all complaining about new records, and a lot of people are changing the mixes. They think that we need to lubricate the surface of the record, make it more, the word is called slippery. That was a word developed back in the 40s and the 50s and the 60s. So to reduce wear, to have a better sound. All these mixes, though, are not allowing us to see the detail that's in the bottom of the groove, where all the breath, imagery, and dynamic range occurs, where now we have the full excursion of the needle going up and down. That gives the artist that wonderful breath. So we've discovered also there's a different way of handling this, because those records will leach all the time. For those of you familiar with our system, and I don't like to talk about our system per se, that we have a method where we change the charge of the record in multiple cycles. And we do that because as the record spins in the cycle number 1, the change of the charge changed with respect to water. And I'll explain why. But the issue is, we see every time we apply that spray, a rise and then a fall of whitish materials. That is what was left over from either manual cleaning, air dry cleaning, vacuum cleaning, films, and then afterwards the release agent. With the new records, I can spend 10 hours and I will have materials come out. So for the new records, we found out that it's 5 cycles in a special timing, and we don't have to worry about it even if we have more leaching. But that validates in the new records of all the pressings that we have changes in the plastic. And again, dust is 3 to 5 microns in size. It's hit and seen by the needle. It makes a pop, and I do not care about bacteria, size that are submicroscopic per se, and I'm using the word of an optical microscope, not either a 3D imager like ours or an X-ray machine. That doesn't affect the sound of a record. So again, Shure in the 70s proved in their own research that there is a release agent. So moving along, some of the discoveries as it relates to record care. So let's bring back that life of the record. So what I'm saying is, let's play the stamper in reverse without any kind of coating. So basically, let's play the PVC, which is the proper non-reverse pressing, without a coating on it. And I like this because this is a great image because it's clean, and especially where, in fact, opposites attract and likes repel. And that's the premise of the Kirmuss charge of water versus the record. And that's the premise of removing the release agent. So number one, first discovery, vinyl and water have the same electrical charge. This has been proven time and time again. Yes, if you take a look at the charge of a PVC record, yes, if you take a look at the charge of water, everyone will say they're slightly negatives. But how does that happen? So let's delve into it. So let's think of this. So here we have two magnets. Okay, two magnets. If we have opposing poles, like we see here on the bottom, they'll attract. If we have poles of the same polarity, they'll repel. So think of one side here in the bottom as the record, and the other side as water, with or without a surfactant, with or without a soap. They have the same electrical charge. So this can be proved if you take a look, if you take a record, and there we go. I have tons of records here. There we go. If we take a record, and if I apply a cleaning agent, so here we are, we have McDonald's coffee from this morning here. There we go. And I pour it onto the record, it pools. Why does it pool? Well, in fact, we do have the water being repelled by the PVC plastic. So, that's interesting. So that goes to the premise of, well, am I really cleaning a record with a cleaning agent? Well, you're surface cleaning because the water is sitting on it. And it's not because the water is doing something. The water isn't moving. You are now using a brush. You're using a mechanical method to apply that water with or without soap onto the record. So there's something that's called the triboelectric series table. It states that PVC in records build up a charge, and we know that. And PVC is non-conductive. That's why we see it used also in electrical installations. And we know for a fact that we charge the record, we get static, we got all these anti-static zap guns. We go to the turntable, we touch the record, we feel it's static. We pick up static with the stylus. So we have electrons, as the turntable also turns, increases the charge of the record. So knowing that we now have a charged record that is now increasing in charge, and where the molecular orientation of the water and the water droplets also have the same charge, while we can reduce the surface tension by using both the soap and water, putting it all together, yes, one side of the soap will adhere to the water, one side of the soap will go and wash away or dissolve the oil from fingerprints and so on, but it will not get into the groove. So just taking water, using one of the little machines that you just put the record in, and we've all done that, spin it around, rub it. Yes, the foam does something, the brush does something, but I cannot get into the record per se, not only because of the opposite charge, but also of the size of the water. So let's now think of something. How can I get into the groove? Now, the size of water droplets, they are a little larger than the groove itself. Now, they're at about 40 to 50 microns on the smallest end, found in fog. Yes, they will go into 1/3 of the way down into the record, as we saw with Shure, but they can't go lower. The detail area is about 6 microns in a curve. So how can I get in there? I need to pulverize, if you want, and the water and create a wave and have something that I can actually force into the record's groove to attract the water. So we use an ionizing agent, which is a bipolar spray. So yes, this goes now kind of away from generics, but you'll understand where if I change the charge of the record, and this will now attract the liquid, the medium, the water, with or without a soap, doesn't matter. But the cavitation effect of creating microbubbles that collapse, they implode or explode and create a plasma wave. Now I'm doing that brushing, but I'm doing that brushing at very high frequency. So that's where ultrasonics properly set up and with proper ionizing processes, I now can, in theory, remove the release agent. So going back to this discovery, here we have a water molecule again. And remember, I just talked about charges of records being opposite to, being the same as the charge of a water with or without a surfactant. Well, why do we in an ultrasonic require or ask to use not deionized water, but distilled water? Well, we want to have the purest water available without any kind of an electrical charge to aid in now adhering to the bipolar surfactant. So the water molecule, in essence, has 2 hydrogen atoms and an oxygen atom. And the predominant charge, as you see here, is the positive on the upper side, but we do have a negative charge. It's basically a dipole, where if we take a look here, if I take, and the proof of this, you can do this at home. Take a glass rod, which is neutral in charge, and then rub it, with a cotton, rub it with a silk cloth. And now what happens is we're removing some electrons from it, and it leaves a net positive charge. So remember, record is negative, the water is negative. Now, if I take that rod and bring it to tap water, it will now move that tap water over to the rod. So that proves the fact where I want now to take advantage of changing the charge of the record to be opposite to that of water. So the record becomes slightly positive, and the water being slightly negative now attracts the cavitation wave. So that's the theory and the concept of what we're doing in charging the record, as demonstrated in proving by changing the charge of water, of the rod, as how it can attract water to a neutral rod. So again, in cleaning processes, I cannot change the charge of the record because the cleaning solutions, monopolar surfactants, they all have the same charge. So this validates the ionization process that we purported, which then allows us now to go in and remove the release agent. So again, the distilled water has no charge. Deionized water is what we do not want to do because it upsets the process of changing the charge. We need to have an induced charge where the water and the record are opposite. By using deionized water, I negate that. And deionized water obviously is made through a process of using filters, ceramic filters, resins. And basically what happens is it's great for even for chemistry. Using the deionized water, you need that because you do not want it to affect your experiments. Cleaning of records with using sonics and changing the charge of the record, I want that. So that's why we do want to use the distilled water. And here again, this goes back to the water molecules, whether it be deionized or standard distilled water. Something also is for the people that are in very humid areas and where we have water damage, we have fungus, the process of deionizing water using filtration and resins does not remove bacteria. And as we know, I can have a very clean record. I apply humidity to it, dust lands on the humidity, the dust and the dirt then creates a living environment, and I can actually have bacteria start to grow and then adding fungus onto the record. So we do not want to wash or leave water and any residues on a processed record. That's why we use distilled water. That's created by evolution, where we take water, we heat it, it boils, the vapor rises, it goes to a contact of a cold area. It then basically, I'm looking at myself here, I'm trying to do it the other way here. It then basically condenses and we have pure water, where in the basin, we have all the impurities still there. So pure evolution is the way to do it. Some people say it's too expensive. So, 89 cents or 98 cents over at Walmart for a gallon. Well, for those that are going to process a lot of records, go on Amazon, buy a stainless steel boiler. It'll do in 3 hours. It'll create 2 gallons of distilled water for about $140 your initial cost, if you're worried about the 89-cent cost. Paul Armstrong over in the UK knows distilled water is like $3.80 a gallon, if not more. So this is a way for people to use distilled water inexpensively. And again, going back to here, I poured this solution on this record. I'm now going to brush in the cleaning, and then I'm going to remove it, whether by a rag, by vacuum, whatever. Take a look at the size of the water molecule, or the droplets, not the molecule, I should say. And remember, at the top, we're at about 35, 40 microns. At the bottom, we're 6 microns. Well, we're over, 75 plus microns in size for a drop of water. That's not going to go into your groove. And remember, we still have the repulsion effect, where we're basically having 2 light charges repel each other. Some information for your cranium. This is taken off the website. This is again using the older technologies of taking a look at what a groove looks like. Grooves are not straight like you saw in one of the snapshots I showed you. They have detail. Here, classical music. This is soundtrack from Ice Station Zebra. The Kirmuss. There we go. That's what the lacquer cut. That's what that's what was cut in the lacquer and then created the master, the stamper. Here's the drum and bass. Lots of movement left and right. This is Ronnie Size Dirty Beats. Here, this is rock, the Clash, the Street Parade. So you can see different styles of music have different excursions of your needle as the needle moves. So the needle moves up and down, left and right. And again, it's dust that is seen. You do not see bacteria here. Bacteria is subparticles, submicroscopic particles. Here you see on the right-hand side here, a piece of dust that's lodged into a groove, into the release agent. Here's an image again taken with our system. Notice this bubbling here is the release agent. I have pictures before and after, again proving that this is a release agent. And not only can I measure it, but I can measure it acoustically. I can take a signal analyzer and I will see on a brand new record 1.3 dB increase in gain by removing the release agent of a record pressed 4 years ago. More in records of vintage, past vintages of provenance unknown. Here again, you see the waves of the left channel and the right channel. These images weren't taken by me. These are educational RIAA images. So here's that famous dust has landed at the factory. It creates that unwanted pop. And here you can see by now I have 11.21 microns removed from this record. Picture on the right is with release agent. Picture on the left is without release agent. Now, I do have to comment on this. In the early days, I did not know that it's kind of hard sometimes to find the exact spot with my microscope. So you can see this piece here. We have this is the O2 record. You can see here we have a piece of music here that's quite active. This one here is quite quiet. They're not the same. Now what I do is I take a knife, I nick the area that I want to look at. I then take paint, I put a drop of paint in that. I've now destroyed my record, but now I can guarantee that I am in the exact two same spots. So this was pre-nicking, and I really like this because we have the audio of this before and after. That's all tied together. So, but it is the same. The pressing has the same thickness of pressing oil or release agent throughout on the same side. Okay, this goes back to the Michael Fremer Scorpion, where here's a 2D picture of fungus on a record. The magnification is 500x. Geez, go back to that slide. Someone was showing 125 or 100x. Well, there's something wrong here. Again, we're using scientific equipment and we're not doing cut and paste. This is all real video, real imagery taken. And here's what the scorpion looks like. That's what Mike Fremer called it, a fungus on a record. And again, you see the detail in the record, left and right, moving around. So let's now take a look at the cleaning processes here. This is what we already took a look at, and just by using mechanics, we just can't do it. So this is also from Shure. Wood glue. Oh my God, let's pour wood glue on the record, let it sit overnight, and let's, it's like exfoliation, it's the new serum for the ladies. It doesn't do anything. Where's your detail? It's over here. You're not doing anything here. And here's the tap water where it cannot go. Remember, I said we're at about 30 microns across in this area, 40, 45, depending on the amplitude of the music that we're listening to, and we're down here in a curve of 6 microns. Water alone cannot clean with or without something being pushed. You can't push it in there, but you can break this down by using an ultrasonic. So left or right hand side, what's clean, what isn't? What's restored or what isn't? This is a dusty record. This looks like a clean record. I can't tell. I really can't, because I don't know what's in the grooves. People on the website are showing you pictures of records. They're shiny. Heaven forbid, WD-40. The shoe polish, lighter fluid. We can have a horrible record if we have the release agent removed, where now the needle is making full contact. And by the needle now being all the way down in the bottle, I call it the pocket. I don't care what's on the top. We restored a record for Audio-Technica at the Expona show 2 years ago. They play this record all the time, and we've all scratched the record with that tone arm going across. I call it the tone arm skid. Oh God, sometimes you hear it every revolution, click, click, click. Well, by now going in the pocket of the record, I do not, 7 times out of 10, based on our restoration experience of restoring records at trade shows where we listen to the record first and play it afterwards, and we no longer hear that click going around. Audio-Technica can attest also, they had a skipping record where they had a piece of dust that was lodged into the release agent, and that record skipped since it was new. We were able to release that. And again, the folks over at Expona show in 2018 were testament to that. So yes, there is a method to the madness. So here again at the home, you create more pops. So again, forget about cleaning, forget about what I'm selling. Use a combo brush, remove the dust, remove the static. If you can have a turntable cover on it, it not only reduces any low frequency reflections coming from your speakers, it will also keep whatever is inside that area within the record and tone arm area and not from outside. Okay. So let's go into cleaning solutions. I will never buy, and neither should you, whether you are cleaning an automobile, whether you're cleaning, pots and pans, whether you're cleaning a record, never buy a cleaning solution that doesn't have the ingredients on there. By law, when I ship my liquid, I need to provide a material data safety sheet. It talks about, and it's registered with FedEx, it talks about what's in the cleaning solution or what's in the bottle. It also talks about ingestion. What happens if someone happens to drink it? What do we have to do? So we need to always take a look and see what's on the bottle. If it doesn't have anything on the bottle, don't buy it. You don't know what you're doing with your prized records. The same thing, once you do have the ingredients listed, always consult the PVC chemical compatibility chart or the poly chemical compatibility chart for poly records, and it will tell you whether the ingredients in that solution that you're going to apply to your record, forget about my process, just you cleaning a record with brush and God knows what, if they're compatible or not. Same thing with drying a record. Remember, we just talked about where the cleaning solutions and the records have the same charge. So whether you're using air cleaning, whether you're using vacuum cleaning, blow cleaning, you will always have water on the record. Why? Because the water is being pooled. Something of interest, a record that's being restored where there's no release agent, you can shake the water off and the water does not pool. That's why we do not use any kind of vacuum or air drying process, because our record, once shaken and restored, there's nothing for the water to, basically the water just rolls off. It doesn't stay there with the surface tension. So again, you need to take a look at what happens. So some other things, cleaning solutions, how long should they be in a machine, in a bottle? Do I reuse it? You know, should I change water out frequently? Well, if you take a look at the provenance of the record that you have at your home, that's brand new, you know that you haven't applied anything to it, and all that you have on the record is release agent and whatever the release agent has got into your groove. But if you're like me, looking at barn finds, looking at boot sales in the UK, garage sales here, looking at estate sales, records of provenance unknown, or inheriting records from grandparents or parents, you don't necessarily know what was actually put on the record as a cleaning agent, anti-static. Again, I remember every time I heard a pop, Lafayette Electronics had a new spray, I'll buy it, and I just loaded my record up with it. So yeah, it was great. I didn't hear the detail because I was a disco guy, boom, boom, boom. So all of that, when it's coming off, ends up somewhere. So it ends up in a tank. In an ultrasonic system, because now we are pulverizing those droplets and now having them actually with an ionizing agent, if you're using it, into the groove, you're now bringing a lot of materials out, not only the release agent, but whatever was on the record before. So we recommend, that you change the water often. Heaven, if you see it murky, immediately change it. I always say every 10 records or so, get rid of the water. Someone says, well, you should, why don't you have a foam filter? A foam filter in your machine. Well, unless it's a ceramic filter, resin filter that is $4,000 or $5,000 in cost, the size of this, and I'll show you the slide of this. This is from one of the machines out there. The holes are 100 microns, 150 microns in diameter. What's the size of dust? Dirt. So 3 to 5 microns. So this is a pass-through. This is, you have the elephant going through the hole here. So foam filters, unless they're $3,000 or $4,000 used in laboratories, this is a $1.99 Ace Hardware special. And yeah, now I have a record that's pooled. I pulled up all sorts of stuff. I have a brush, and now I'm either taking a cloth, I'm using a vacuum. I'm leaving a residue on the record, and I can measure it. And again, like I said, if I can measure it and then remove it, I know that someone's deposited something on there. So here's a question. Would you buy this famous ultrasonic magic elixir for records? This actually was sent over to me by Mr. Fremer. I said, well, let's take a look at the ingredients list. No ingredients. Wow. What the hell is it? Okay. No, I wouldn't buy it. No list of ingredients on the bottle. Is it safe for PVC? What about ingestion? What about cancer-causing agents? What about special disposal? Well, what is it? It is, oh my God, glucopropyl oligomeric disyloxide, blah, blah, blah. Anyways, this is the recipe for what it is. Long story short, it's made by the California prisons industry. It's an industrial cleaner that's a restricted product. On page 1 of 8, it says 12% is of unknown acute toxicity. It has an ether. So if you now take all of this and you punch it into the PVC chemical compatibility chart, it says don't use it on vinyl. What is it? It's used to clean jewelry. It's not used to clean vinyl. Heaven forbid. What does an ether do? You speak to anyone in plastics, it makes PVC brittle. That's why cleaning agents that have alcohol, high percentages of alcohol, there's a caveat to that, that destroys the plasticizer. The heat of the dyne of the needle now is basically damaging your record. How do we know it? When I remove the release agent, I now sometimes bring the level of noise up from the record because the plasticizer was damaged by an alcohol in a cleaner. Everything is measurable, whether it be by signal generator, amplitude of the cartridge, what goes into the phono stage. We can measure all that, and I can see the damage of records. What about this one? Geez, it says Turgitol. Oh my God, Library of Congress said you should use it for cleaning of your records. My goodness. What is it? Go to the safety material data sheet, go to the manufacturer's website. What is it? It is an ethylene oxide with ether. What is ethylene oxide? It's a solvent. It's used in paints. It's used in plastic production. The chemical compatibility chart says it's a no-no. The material safety data sheet, it says it's a cancer-causing agent and it has restrictive access, and it has to be properly disposed of. Very nice to put on your record. So after you've heard my monologue, discoveries. Okay, so what do you think about this? You just bought it, you got it for a Christmas gift. Well, you want to take a look at the bottle. Are the cleaning agents safe for PVC? Is this going to go and clean into the groove? Well, we said water and cleaning agents, the same charge as a record. The droplets of water are larger. I don't think so. Will they coat the residue? Will they coat the record with the residue? Imagine applying a fan here and just blowing air onto this to dry it. Well, it's going to pool water. I'm going to dry. I'm going to maybe use a cloth. Well, yeah, I'll probably leave a film. About here, are the cleaning agents PVC friendly? I don't know. I have to read the label. What about the mechanism here? Can they reach? A question today was, can I reach deep into the grooves? Well, if the brush has a 10 micron brush and is brittle, yes, it'll get into the groove. Will the liquid, the water make contact with it? No, because the brush won't break it down. Will it leave a vacuum? Will the vacuum leave residue? It could if the solution wasn't run a couple of times, where I've now put distilled water on this to remove whatever was from the prior run that I did pick up off the record. And what about static and moving air? Is there a Venturi effect and static? Well, I don't know. It depends on your humidity, about your environment. But by having those 4 or 5 little snapshots that I gave you, you can kind of figure out, what's the forest between the trees concept. What's real, what isn't. And again, here, soaps and water, they're repelled by the record. So is this safe? WD-40. We have 2 record dealers in Denver that shine up the record. And they sell the record for $40 for the same artist, or $4.99 for the same artist with a lot of scratches. I remove the release agent. I see the scratches. I don't care. And as long as I don't have a very deep nick, my needle now is in the pocket, and I get the full brilliance of the artist as it was made in the lacquer. Okay, so let's talk about ultrasonics now. So everyone, there are a couple of things in ultrasonics. People say highest frequency is better. 25 kilohertz sucks. 125 kilohertz is great. 100 kilohertz is great. 800 kilohertz is great. The more power, I get rid of everything. Well, we have a plasma wave created. When the bubbles are created, it creates a wave. We're not dealing with the bubbles, we're dealing with the wave and impact of a wave. So just put that in the back of your mind. What about the cleaning agents put in? Are they taking care of the ionization fact of the record? And actually, are we actually removing everything on the surface and in the grooves that we were purported to do? So long story short, I don't like reading things again, but basically with the diagram, here we have ceramic transducers. That's the latest generation of transducers that are located on the bottom of a tank, typically, a stainless steel tank. And what happens is they're excited between 20 and 40 kilohertz, or 100 kilohertz, or 125 kilohertz. And now the mega sonic technology, 1 megahertz. And what happens is these generate bubbles, and these bubbles rise. And there are millions upon millions of these. And the size correlates with the the frequency of the exciter or the transducer. So what happens in a basin is that on the bottom, obviously, we have the highest signal. But unfortunately, what happens is it's not very uniform because you have the spaces in between the transducers. We have uniformity more as we go up higher. And as the bubbles implode as we go higher, we then have more even coverage. So this is the area that I'm interested in tossing or popping a record in. Okay. Now, going back to frequency, and I'm going to, I can't say this any other way. When you are a manufacturer of ultrasonics, you understand that different frequencies are used for different aspects. The 125 kilohertz frequency is generating 1,200 mile per hour wave, and the bubbles are very, very small, high impact, high velocity. Why? Those ultrasonics are made to clean off bacteria off silicon wafers. They're used to clean the colonoscopy cameras and the tubes and whatever that go up your posterior when you get a proctologist that's working on you. You have to take a look at frequency versus what is the material that you're cleaning. Okay, think of that. We have a record. It's soft. It's fragile. Heaven forbid me ionizing that record and using 125 kilohertz ultrasonic. I will damage that record because I've now attracted that wave. No one uses this attraction of the wave. That's why we're very specific and say, please don't use our ionizing spray on any other sonic because I can't guarantee what the frequency is and what we're going to do to the record. I'm trying to remove 3 to 5 microns of dust, soft, oils and grease from fingerprints, fungus. I am not looking at any bacterial processes. So frequency, the lower the frequency, the larger the bubble, the slower the wave. So here, if I'm now creating this cavitation, it's now, again, at this item that I'm cleaning. And of course, if they both have the same charge, they will repel. Okay. Something very important is we have an effect called pocketing that occurs in ultrasonics. And someone says, why do you degas your ultrasonic? Why do you kind of pulse that ultrasonic every 5 or 6 or 8 records? It's because, remember, if the record has a charge that's the same as the water. When I put it into the tank, I will now disperse or displace that water and introduce air into the sonic. So sonic cavitation effect depends on making bubbles. If I now have air increasing in content in the tank, I now basically am reducing the efficiency of the sonic. So that's why we need to have a wave, standing wave created. So a push-pull instead of a like this, where bubbles are rising, to break down the air bubbles so that now I have water back into the tank. So again, in a 6-liter or 1.78 gallon tank, we need to take a look at also now how to take advantage of the zones for cleaning efficiency. So something that's very important. Some people, there was a company at Expona that had 50 or 100 records in an ultrasonic machine spaced by 1/8 of an inch. Well, whether it's 1/8 of an inch or spaced 3/4 of an eighth of an inch, where in a 6-liter, 1.78 standard size ultrasonic, I have 12 records in there, it ain't going to happen. You will not have the cavitation rise going from the high intensity, relatively uniform area to the top and reach all of the recorded material to the needle takeoff point. It ain't going to happen because of standing waves. The records will send back the signal back to the transducer. That in turn creates heat also, which will heat the water. So the effect of cavitation creates heat, but the standing wave will also increase heat because now we have a signal coming up and now we have a reflected signal coming down because of the spacing of the record and the size of what we put into the ultrasonic back. So amateur radio CB operators understand that if I have a transmitter here, 5 watts ERP, and an antenna here, there we go, an antenna here that has, forget about the gain, just unity gain. If I have a bad connection in between both with the coax, the 5 watts coming out here, going to the antenna may be 3 watts because 2 watts is going back into the transmitter. And if it's too high, I blow the transmitter. Same process in an ultrasonic, where I want all that energy to come up with the least resistance. The more resistance, the less cavitation effect, which means I do not clean the entire record or restore it. So here, record suspension and surface contact in this. Well, if we take a look at this, this is a 7-liter tank there, and taking a look at this, knowing this machine and this homemade fixture, I'm not reaching the last song and a half of the record because the water is too low. I need water to make contact with that record. So I need to take a look at making sure that all of the recorded material is touched. Here's the famous skewer. 12 records on a skewer machine. There we go. There, that's my homemade tester, and I'll tell you how you can make one yourself. Records are spaced 3/4 of an inch. What about records at 1/4 of an inch? This negates the efficiency of the ultrasonic, and you will not be doing and touching, except for the water touching the record, you won't be hitting 2/3 of the record. How do we prove it? I'll tell you and show you, and you can duplicate it at home. And we're nearly done here. So here it's about, we need to analyze first before selecting an ultrasonic. What are we cleaning? Soft records, 3 to 5 micron size of dust. So basically what we're interested in is not bacterial cleaning of 125 kilohertz or 100 kilohertz. We're looking at 35, 40 kilohertz. So that's the sweet zone to be able to, with ionization of the record, to remove the release agent and the dust. We're not dealing with submicroscopic bacteria. So that answers the issue of frequency. And you know, don't read the blogs. I'm sorry, everyone's an expert. Mike Fremer said, don't get on a blog. You answer one, you'll have 5,000 arrows coming your way. and 4,000 you're going to shoot back, and the other ones that hit you, you're going to get another 10,000 that you have to explain more. This is all based on science, dealing with not audiophile companies manufacturing ultrasonics, but commercial ultrasonics used in aerospace, in homeland security. I have a homeland security company. We use a 25 kilohertz ultrasonic made in part by the manufacturer that makes mine, that I change for my own reasons, to clean circuit boards, to clean aluminum. In '78, I worked on a space shuttle in Montreal for Spar Aerospace, 6-foot long ultrasonics, 50 transducers inside. What are we cleaning? Microwave elements and so on for space shuttle, TDRSS satellites. And the contact is, I spoke with these manufacturers of equipment, sonics that are made in the hundreds of thousands of dollars. So this is their science. I'm just repeating it. And again, I have all the references for you if you question what I'm presenting. So here, what we found is 35 kilohertz is the sweet spot. It'll do the 2 to 5 microns soft removal of dust, removal of fungus, removal of surface oils, and it creates a 500 mile per hour wave versus 125 kilohertz ultrasonic that's made for bacteria that's 0.5 microns smaller. Your needle doesn't even hit that and hear it. And it has nothing to do with removing the release agent to discover the music from the artist. And we add a 70 kilohertz resonance in there, which evens out the distribution of the bubbles. Remember that slide where the bottom area is more even, the top area is really kind of wishy-washy. By the 70 kilohertz resonance created by the physical structure of the base, we now have an even distribution of the bubbles on the record. And I'll prove that to you on the aluminum test. So here, again, you need to change the charge of the record with respect to whatever you have in the tank in order to get into the grooves. Otherwise, all you're doing is surface cleaning. I can put a record in my machine with distilled water and let it run, or use one of the soaps that's out there. It will do nothing to remove the release agent. Again, because of the charge of the record. We've measured that. No change in the thickness of the release agent or the disappearance of it. Add the ionization? Yes, it does. Don't use the ionization on 40 kilohertz or higher. We will sandblast the record. Again, the deionized water reduces the effect of using even a monopolar surfactant, which are the typical soaps that are out there, or a bipolar, which I use not as a soap, but as an ionizing agent. Okay, so the basics are all done. Now I'm going to just validate the process and and it'll talk a bit about the product. So what we did, again, the same process is we found out that the spacing of records is very important. And we also have to suspend the record at the proper height so that we are removing the release agent from the second to last blank space before the needle gets picked up and before we actually hit the label. We want to remove all of the material in where the recorded data is. Ionizing the record now changes the charge of the record, so it affects now the cavitation effect, now being able to being attracted to the record throughout it and not repel it. In our process, as the record spins, 2 minutes, for example, for a new record, we take it out, we apply the ionizing spray, changes the charge of the record spins again for 2 minutes. As it's spinning, the charge is reverting to that of water. That's why the Kirmuss system isn't a pain in the neck or a pain in the posterior. The process is, let's remove first the films left over by prior cleaning processes. And as we bore down in the cycles in and out of the machine, we now go and remove the release agent. First, we remove the dust that's stuck in the release agent, then the release agent, then down in that 6 micron small bottom area where all the music and the love of the artist and the breath of the artist live. That's the process. So yeah, 4 5-minute cycles, or 1 5-minute, 4 2-minute, 1 5-minute, and we've restored a record. And then at the same time, because of that, forgetting about the microscope, you can measure it by your needles on the amplifier or preamplifier. If you have an MPI4 or MP4 from Macintosh, it's the oscilloscope analyzer that they have. It can measure output out of your cartridge. It can measure cartridge alignment as well, left channel, right channel. It's a scope. You'll see 1.3, 1.4 dB gain on a brand new record and 3 to 4 dB gain signal output to the phono stage input on a record of vintage unknown. So you can do that with your own meters. You don't need to measure the release agent, and you'll hear the breadth of the music. So simple tests. The test for all manufacturers is using an aluminum foil. At Spar Aerospace, we had on the bottom of this aluminum foil a piece of balsa wood that was 6 foot long, because this was a tank that was 7 foot long. And then we made a frame left and right and glued the aluminum on the frame. Here is, I have my frame here. Okay, I had a frame that I used to test another problem we discovered. But anyway, so this is what I did with a record. I used balsa wood. I made it the diameter of a record. I put in some cross pieces, just because the aluminum is flimsy. And you know, an ultrasonic works is when that aluminum gets pitted. So pitting, so you put it in the machine, and then in this case here, my record turns for 5 minutes, or whatever is the setting of the manufacturer. One of the systems that we tested, you press the button and the machine starts. It does its thing. The fans go, it dries the record, and then take the record out. And then what you do is you look at the pitting on the record, or sorry, on the aluminum. So test number 1, does spacing affect cavitation? You saw the skewer. We got 12 records in a 6-liter tank. Well, what I did is I created, in this case, 4 records. I kept one out because this machine comes with 4 record spacers. They can put 12. They're all spaced by the manufacturer. There we go. I did have little spacers in there to keep them from going, but if you take a look here, there's the spacing, and we have aluminum foil on both sides. And then put it in the machine. It's the same size of the record, and let's see what happens. Did we meet all the requirements? So here's the test before. I use the manufacturer's spacers here. As you can see, record 1, record 2, record 3, record 4. The back section had just some added support, so that so I'm interested in making sure that this doesn't vibrate too much. And there we are on this one here, 4 records skewered. There's this manufacturer's skewering mechanism, and presto changeo. So this is the machine, 40 kilohertz, 4 record kit provided by the manufacturer. And there we go. So this is record side number 4. So this was the record closest to the motor, the right next to the wall of the 6-liter ultrasonic basin. Side A is in the back, side B was in the front. And as you can see here, I drew a little line here where we did not have the ultrasonic reach this area. This is the furthest record from the tank. This tank had 2 ultrasonics here and 1 in the middle. And basically, this record was not processed. And it only went about 2.5 to 3 inches instead of going the 4 plus a little closest to the label area. And this is this manufacturer's cover of the label. So very little dimpling on both. This is record number 3, side A. So here we are, we're 1 away. And we see that we have now approached closer to the label area or to the record takeoff area, but the ultrasonic cavitation, very little. And we saw on this side here, side B, huge amounts of destruction. Remember in that slide where they showed you the bottom is very uneven. The middle is the sweet area, and then you have high intensity spurs up on the top. This proves what the design is of a 40 kilohertz ultrasonic, where yes, while this record is turning around, the cavitation is riding, and I'm having major explosions of the micro bubbles. So let's take a look at the next record. Okay, here's the second record. Again, side A is the back, side B is the front. And here we have better cleaning. We still have that same area where the ultrasonic did not reach. And yet we have more pitting. You see there's more pitting here. More pitting. Here we go. Let's see, which side do I have here? This is okay. Here. I'm just trying to. Here we go. There. So here, this is what this looks like. This is a record. This is that record number 4, and you'll see that there's very, very little pitting. There we go. Here, there. There. Very little pitting, very sporadic. So you have no ultrasonic in a skewered system. Doesn't matter whether it be this manufacturer, doesn't matter if it's a higher frequency, it just doesn't do its job. And here, record number 1 is the worst. Well, we have terrible, terrible cuts and tears in the aluminum foil, and unevenness again in the coverage. But we are now approaching the 3 3/4 inch zone in the record. So we are approaching the 3 3/4, which would be the just below the takeoff area. Now, I have seen records, and I have some records in my collection that go all the way up to the end, and they weren't K-tel records. So you would not be able to have any processing in that. So that's the test number 1 of this manufacturer and its concept. Some other observations: we filled the water to the maximum line as requested. But if you take a look at here, this is where the label starts and goes to the center hole. Whoops, sorry, there we go. Let me go back. There we go. We have 1/4 of an inch of water that is not touching the area that we should, because it is what it is. So this, in fact, does validate the result that we see in the slides that I just presented. Okay, here's another machine here. Here we've created again, the same thing. With respect for the manufacturer, we have a white box on the machine. So this machine is advertised as, here, cancel. This machine's advertised 40 kilohertz ultrasonic. Press the button. The machine does all sorts of things. It scrubs the record. You see foam bubbling up and all sorts of stuff. And the record stops. The record is dried with air, and out it comes. Well, the unfortunate part is when we take the record out, there's side A, there's side B, and if I take this here, there we go. Here, there we go. Those are mixed from my fingers, or there is no micro dots anywhere. There's no impacts anywhere. This is not an ultrasonic. It is an ultrasonic bubbler that bubbles. And in this machine, what we had to do is we had to remove some of these felts so that they don't get caught up in the flimsy aluminum. So that's the only change that we did with this particular machine. And when you open it up, it is not using ultrasonic transducer technology to create a wave, a plasma wave in the tank. So this is just a surface cleaning machine that uses brushes and air dries. And then we did not trust it, or we said, no, it can't be. So I made a square piece, and I put a square aluminum frame in. I removed the rubber on the bottom. There's a little capstan in there, and again, nothing, zero, no cavitation. And if this was an ultrasonic, a technician would say we have to repair it. So, not 40 kilohertz, I used the wrong thing. This is the 35 kilohertz. I did cut and paste. This is Kirmuss, so we got to change this before we publish it. So this is our machine, and people say, why can you not put more than 4 records in a 6-liter tank and they're spaced by 1 7/8 inches? It goes to the fact where we want to be able to reach everything. So here's record side 2, side B, closest to the edge of the tank. Just so happens that the previous machine was a 40 kilohertz machine made by the machine manufacturer that we use. Ours is 35 with the 70 kilohertz resonance that I change at my own factory in Shenzhen, which I've had since 2006. And you see even spacing. Look, the dimples are even. Same thing on side A. Now you see some areas where you do not have any dimpling. That's the balsa wood and the gluing of the aluminum foil. But look, it's even all the way to the last area, 3 5/8 inch, and there's the label mark right there. The same thing with record number 1, right over here, it's even. So that proves that the closer records are spaced, the less activity you have and benefits of the ultrasonic. And that's it.
I would like to ask Charles more about his, this is kind of like a delicate question for manufacturers, but what is your product like? Have you had any problems with these machines? What is the quality of your motor and how many thousands of hours do you think they'll last? Things like this. If you're buying this machine, do you expect to get a good one and for it to last, 10 years, 20 years, 30 years without any problems?
Well, Jonathan, I'm sure every manufacturer will say they make the best products and so on, but we've sold over 5,700 of these now since 2018 from Expona. And in RMA numbers, we're up to 17 in nearly 5 years. The majority of those have been where we've had people that have seized, 3 of them have seized the motors, where they do not empty the water out of the tank at the end of the day. And what happens is if you don't do that, and if you keep the water in for 6 months, when the water evaporates, we have surfactant, prior cleaning agents. They then stick up the gears and then basically blow the motor out. The product has a mean time between failure of 50,000 hours. It's being regression tested for that by Underwriters Laboratories, specifications by ETL Laboratories. Guarantee the unit, for 2 years. And quite frankly speaking, I'm being very honest, and I've been a manufacturer since 1976. I'm the repairman, and I'm not busy.
Okay.
And again,
What is the
I don't like
procedure?
answering a question like that, but we take a look at the rubbers, we take a look at mean time between failure. It's my factory. We burn in everything. So, it's the 3 rule: 3 seconds, 3 seconds, 3 minutes, 3 hours, 3 days, 3 months, 3 years.
Okay. What is the procedure for ordering one if we wish to take advantage of the discount?
Just give me a phone call. I'll check with Mark that you were here. We take a credit card number down and we ship it from Denver.
Okay. Thank you very much.
Okay, thanks.
And email. Just send me an email too. And we don't have a store on the website because we like to support our dealers.
Oh, and by the way, I asked you earlier about the machine available on Amazon, which
Yes.
you do not provide that machine to Amazon.
No, we do not. We have a strict policy where our dealers are not allowed to sell on Amazon. We do have a distributor that was liquidating equipment, which probably still is. Some of them says there's no stock. We like to support people. Kevin Deal over at Upscale Audio has the 3LP version. We have Elusive Disc. Those are our 2 nationals. Then we have, some regionals like in Chicago, Home Audio. Montreal. We got Paul Trepanier over at Ultrasonic. So we like to support the brick and mortars. You mentioned Stereo Unlimited. Someone did. We did a record cleaning session there before, after. We're not just a manufacturer. We love music. That also perhaps is a difference to answer Jonathan's. It's not just we live with the product, except for now the phone runs 7 days a week. So
Very good. Thank you. And Rob, you have your hand up next. Go ahead.
I have two questions. One on the mold release stuff. I just want to be clear that I understand. It's sort of oozing out of the PVC and other things. I know.
Yes. Mm-hmm.
It's not, the old audiophile myth that it was being sprayed into the stampers between each record, which
the people put a spray on when they had problems with their PVC mix when in the 70s. Remember when the Chevette came out? Well, that was in Canada. I think they called it the Pontiac 100, and we had the Pinto. The prices of gases soared, and the records in the 70s, early 80s were horrible because they say, "How many Elvis Presley records do you got?" "Oh, we got 50,000 here. Let's chop them all up with the labels and put it all in the mix and create wonderful vinyl." They had to add stabilizers and plasticizers, and again, all of that. The record pops out because this comes as a lubricant onto the surface of the record from the PVC. So you're correct; it comes from the PVC mix, and that's why at Cascadia Records you saw where they had to go and put a polish because they didn't adjust their machine's temperature to accordingly accept the new mix of the biscuits.
Okay, and the second question, did you see, it's kind of obscure, but back in the 70s when Audio Critic was a magazine, they did an article, I think it was written by Andy Rappaport, who had designed preamps and step-up transformers. He said he'd been doing some research that found that the stylus doesn't actually play the surface of the groove. It's indenting into the groove by, I forget the exact dimension, but it was something in angstrom. So it's being moved by slightly below the surface of the record, that the surface of the record is like flowing around the stylus as it moves by it.
Well, there are a couple of things in that, and I'm going to also kind of put a plug in for J.R. Boisclair that deals with adjusting your tone arm. When we create a records, the lathe actually is a linear tracking head. Okay,
right.
We're not using a pivot like in a tone arm. So in his experiment, when you're now trying to say, well, I'm not hitting the surface of the record per se and hitting a scratch or whatever, again, depending on the position in the record from the edge to the center point, I will be picking up more or less of scratches that are visible or, well, first visible and then audible either on the left channel or on the right channel as that tone arm moves across. And that kind of goes back to where, if I take a Radio Shack or Assured record of 1,000 hertz tone, I will hear it fade from left to center to right as the tone arm moves around, and depending where the arm is, and they just made a single track of 1,000 hertz, which is a standard, you'll hear differences. And if you have that scratched, I'll hear scratches, and the best is to nick. The best test is to take a ruler and nick right across the record. You can't control the depth, unfortunately, but nick a line, and you'll hear that tick appear on the center, the middle, and then on the right channel. And if you go deeper in the groove, you will 7 times out of 10 in our experience with records that are handled not scientifically but by audiophiles, we won't hear that tick. And that's why I promote buying records that are surface scratched, because he is correct. You will not pick up those surface scratches unless they're very deep. So the record looks like SHIT after you processed it with our system, and I will not hear any surface noise generated from the surface of the record. So he is absolutely correct.
So it is true, number one, that the vinyl to some extent flows around the stylus. Presumably it heats up also. Is there a waiting period that we need to do before we either clean a record or replay it after you've played it once?
The rule of thumb, and I've been able to measure that, is, and I didn't spend more than 2 days. What I did is I measured a record before playing, measured the groove, measured the record after playing, and I had a 0.015 micron change. And then the next day, I measured the same nick spot. Remember, I'm now nicking it, and I'm back down to normal. So everyone used to say, don't play a record more than once every 24 hours on the same side, to let the plastic pressing go to what the plastic specialists call the resting point. And that's why we use plasticizers in records. It's not to make the record flexible. It's when I play the record inadvertently, that plasticizer also allows me to go to, again, the term isn't invented by me, it's called the resting point, where that was the exact pressing that we had made from the stamper.
Okay, thank you. Who is up next?
By the way, that's very apparent. When I restore a record or someone restores a record, I get a call every so often say, oh, side A record, the track 4, boy, does it sound horrible. And the rest of the record is beautiful. I said, what's on track 4? House of the Rising Sun. I said, you play that do you play the record all the time from start to end, or do you select a track? Oh, that's the track I play all the time. As a matter of fact, I think Paul Armstrong, who's on the line here, met someone at the audio show in the UK where he came in, and he was listening to a record that we restored, and that track is being played all the time. So it goes back to, don't play a record more than once a day, same side.
Okay, very
good. Now,
good.
if you want to go and test audio systems like Mike Fremer does, I'd have 5 records of the same pressing, perhaps not of the same quality vintage as Michael's, but like if you see some of the slides I've made of that 02 record, to do my tests of humidity and hot boxes. When we started this 6-7 years ago, we took 10 records from the same pressing and subjected them all 10 at the same time in a heat box, hot thermal vac and whatever. So go around with 4 or 5 records if you intend to listen to 4 or 5 rooms to the record that you know, versus playing the same record all the time over and over in that same track in that studio.
Right, good idea. Brian, go ahead, unmute yourself and ask away.
Yeah, can you hear me?
Yes, thank you.
Oh, good. All right. Charles, I just wanted to first thank you for doing this today. I learned a lot. Have you ever used this product, Liquinox, or what's your feeling on it?
Well, like I do, like anyone should do, take a look at what ingredients, what's on the ingredients list.
Mm-hmm. Okay.
Take a look at the bottle.
Oh, you want me to do it right now?
Yeah. I may recognize a chemical, I may not.
Okay, the print is extremely small.
Oh, you're like me.
Let's see. It's in 6 different languages too.
It says don't read.
Yeah. Okay. Yeah, it's got oh, what the hell.
Okay, here.
Contains sodium xylene sulfonate.
Okay, so
Alcohol. Okay.
Alcohol. Okay, I mean, as soon as it says alcohol, you do not use it.
Alcohol ethoxylate.
Alcohol ethoxylate is a derivative ether, which is also part and parcel of the turgitol family. You do not use that on PVC.
Right. Yeah. Speaking of turgitol, which is probably my second question.
I saw that come in.
You referenced the NP40, which is the 15S-40. That's a really aggressive turgitol. It's used in the textile and paint industry. My understanding is the Library of Congress is using the S9 version, which is,
Yeah, the S9, and they both have ethylene oxide and they both have ethers. They're not supposed to be used on PVC. Now, the reason why I selected the other one is that I've been exchanging emails with someone as a result of this session over the last 4 or 5 days. And we've gone into, I don't know how many pages of back and forth going back. And I said, look, this is from the scientists, and forget about anything else. It's a cancer causing agent and it's restricted. And, you know, we have people that are dangerous to themselves where they read a journalist's blog and then they start making their own concoctions. We got one journalist in England saying that, the Kirmuss solution doesn't clean. It's not a cleaner. It changes the charge of the record. Has nothing to do with the cleaning. You apply it on a record, we're coating the record. It's, like this, what you do is Google, just say PVC chemical compatibility chart. If you're using an ultrasonic machine or some vacuum machine, look for the rubber compatibility chart and take a look whether those cleaning agents are also going to affect the neoprene rubbers or whatever that are in the pistons and whatever of some of the machines that are out there. So do they affect the machine? Do they affect the plastic? Do they affect the rubber? And then you make your decision. But the moment that you see the ethyl alcohol, you do not use, not on PVC. And the issue is it'll affect the plasticizer and you may not discover it until you've used a restoration system where by us removing the release agent, which is kind of a lubricant, you now have the plastic that's brittle. And there was a specific word used by Capitol Records, and they called it brittleness, a brittle sound that came out.
All right, thank you, Brian. Frank, you're up next. Go ahead.
I just want to know, is the 3 LP version available for everyone?
It's exclusive only through Kevin Deal over at Upscale Audio. Yeah,
Is that Colorado?
I cannot offer it. I can't sell it. It's it belongs exclusively to Kevin.
Oh, okay.
But anyone can, if they get a machine from you, they can order it from Upscale. Is that what you said?
Well, no, they have to buy everything from Upscale. Yeah,
I see.
I think yeah, it's $1,200 for that machine.
Okay, thanks.
I had just one other question.
Sure.
And is most distilled water goes through reverse osmosis or is ozonated? Is that an issue?
Okay, distilled water by law, by the Consumer Corporate Affairs Act in Canada, I can't remember what it is here. Distilled water means it was 100% created by boiling, by evolution, and then condensing the vapor back to water. You cannot, it's not through osmosis and so on. It doesn't use ceramic filters. It is the most purest form of water out there. And especially for using it in sonics, as you saw with the molecules and the charges, you do not want to use a deionized water because it'll defeat the purpose of breaking down that surface tension and attracting water into or onto the record.
And once the water is deionized, if for those of us who have an RO plus DI system, does it ever reionize, or is it just like no good for cleaning records or using your system? It's no good, period, ever.
Yeah, it's no good, period. And I happen to also be a first responder. I'm director of search and rescue here for 3 counties in Colorado, and we've been out to Katrina. When we go out to the hurricane and the tornado areas, people that have home distillation systems like you're describing, we put stickers on their windows and papers on their windows saying, do not use your system because it will not remove bacteria. Those systems will not remove bacteria because the premise is everyone needs a little bacteria. But now when you have floods and you have the effluent and excrement coming out of your sewers and the streets getting back into the filtration plants, you're now thinking that your distillation process at your house is going to save you. It's going to get you sick.
And you had said that the bacteria is so small, the needle can't actually even see it. But is the problem that the bacteria grows?
Not at the submicroscopic level and not in the quantities as you see. You see, this is where you have venture capitalists that go, there are two manufacturers, they've gotten some crowdfunding. Oh, here we are, ultrasonics, they happen to work in the chip industry. We're going to use 125 kilohertz ultrasonic. Here's a picture of bacteria, blah, 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 and here's your record. You cannot remove at a high frequency the oils and dust as efficient with a high frequency of 100, 125 than 35. You can't. It takes more energy to do that because that's not what the purpose was of that frequency. So if we're taking a look at medical instrumentation, we're looking at silicon wafers, we're looking where contaminants are going to cause what we call gold migration when we make chips. Very, very, very important to remove bacteria. A record can't hear bacteria, and that's not the premise what we're trying to do. We're trying to be able to get the needle into the 6 micron point, not less than 0.05. My groove is not less than 0.05 microns. It's just a sales pitch, and again, no one teaches about basics of sonic technology and standing waves, plasma wave. I've been criticized using the word plasma wave. I did not invent it. That's the wave created by cavitation. It's in the dictionary, so anyway.
Okay. I'll shut up and let's get to some more questions. Miguel, go ahead.
Hi, yes. I had the question about the difference between ethylene glycol, which is, I think, what you use in your liquid, versus propylene glycol. Thank you.
Okay, we do not use ethylene glycol. We do not use propylene glycol. We use propandiol 1-2-178, and it's not an ether. Again, there are, Miguel, if you go onto Google, just Google PVC chemical compatibility chart, and there are 3 or 4 that come up. Use the one that you like best, and then in one of them you type in what you have, and it will tell you the gradient of whether it's safe or not for your records. It'll give a resistance rating, whether it be a numerical or a D, destroys, N, no effect. I don't have that right in front of me here, and I know I've been asked that question several times. I respond to email, and then I take a snapshot of the chemical compatibility chart. But we do not use that. We use a propandiol.
Okay.
All right. Thank you.
And we use 1 to 2%, and we don't use it for cleaning. We use it to change the charge of the record because it's a bipolar surfactant, not a monopolar surfactant.
And Miles, you're up next. And by the way, I wanted to apologize at the beginning of the meeting, when I named all the audio societies that were invited, I neglected to say that your website, Audio Nirvana, also put our meeting notice up. And so we have some members of your forum in the meeting today. So thanks for that, and go ahead.
Cool, thanks, Mark. Thanks, Charles. That was kind of a hard lecture talking about 70 years of records or so in your time. But I just had one comment first. You mentioned the ethylene oxide. And when I was in cancer research back in the 70s, we stopped using ethylene oxide because we used to use it to sterilize incubators. We used to grow tissue culture because it was carcinogenic. So they actually took it off the market for use back then. But I had 2 other questions. Number one, you talked about dust being a source of pops and ticks and stuff. And I was just wondering, and imperfections in the record pressing process. But I think another thing tends to be nowadays, because the lacquer quality tends to be worse and worse, that it's hard to get just even a quiet lacquer, and people are recutting lacquers several times to try and find a quiet cut. And the other question I I had. So, oh, excuse me, just so in that. So I was wondering what percentage of the record pops and ticks do you think are actually due to the step before the pressing as opposed to what you see on the record? And the other question I had was, what I find with doing ultrasonic cleaning with the machine that I have is sometimes I need to re-clean it maybe after 5 or 10 plays because I find it actually sounds better redoing it again. And I was wondering with your process, do you find, or how long do you recommend between cleanings, that will make a sonic difference?
Miles, very good questions. First of all, when we remove the release agent, I will say that and this is in brand new records, not records where people have had record needle drops and whatever, like we've all done, poof, and it's not at the beginning, it's right in the middle of a piece of music. I won't be able to remove that. But in working with record manufacturers out in UK and here, in removing the release agent, I basically have a quiet record. I have not run into, at least in the few records, and by few I say maybe 20, 30, or 40 that I've specifically, listened both sides attentively in a nice system like the one at my home. I don't pick up any of the issues that people are having on the cutting side.
Mm-hmm.
Now, there is a science also on the cutting side, but more importantly on the plating side and on maintaining the cleanliness when we do the wash, when we do the silver plating, the nickel plating, and the quality of all. That's where, from again, what can be seen. I've looked at two lacquers, and ones that were coated, plated, and I saw dust particles embedded in them. And so the analysis of looking at the lacquer and the original mother ready to make the masters, I've only looked at two. And this particular pressing outfit had issues where they're saying we're having problems, and it goes back to the contamination in the plating process,
Okay.
Miles.
Yeah. Okay.
So that's what I've experienced. And again, as someone that likes a scientific method, that's what I came down to when I was able to see that contamination.
Oh,
You
the
had
other
the second question.
cleaning.
Once the release agent is done, we don't have to do anything in the process that we do, where we try to see the rise and the fall of white materials that were deposited on the record. But, we all have skin oils. We all touch the record. We'll sneeze it. In the olden days, you had cocaine dust with McDonald's grease and whatever from French fries on the record. Once every so often, put it in a machine for 5 minutes and that's it. But it's more on how many times you handle the record, because that release agent also is a prime area to bring in the dust, and then the dust then brings in humidity. And if you have a paper record sleeve with humidity, then it will create fungus. It's a living element. So if I remove the element that captures all that, then it's just basically removing what I've deposited, that I'm not interested now in going down into the release agent.
Even on older records from let's say the 60s that I open that are new, I find these little, I call them pressing pimples. I always assumed that they were flaws from perhaps moisture in the vinyl PVC mix that got released as steam or something. What are those things? You know what I'm talking
I have not seen one, so I can't comment on it. But what would be interesting is, Brian, is get my address, send one of those records down, and I'll put it on the microscope, and we'll take a look at what it is.
I know what you're talking about, Brian, and because sometimes you can hold a record up to the light, and on a blank section, particularly if you have a record with a big runout area, you can hold it up to the light and you see lots of little.
Oh yeah, bumps. I mean, some of them are very easy to see.
Yeah, it's easy to see. They're bumps, and obviously, I don't. If a groove has been cut through a bump in the vinyl, I don't know what effect that has. I would imagine if the bump is big enough, you'll hear it.
Yeah, looks like the bump is actually lifted up from the surface and the groove is over the top of it. And it actually makes an audible thump, like a low frequency
that's-
thump when it rises.
I think that happened a lot in the records from the 50s and 60s. Like I would see, especially like the old Mercury Living Presence. That was
Right.
one of the defects I would see there, like dimples or bumps and those were just pressing defects, I assume, back then.
You even see them in RCAs from the Indianapolis plant, even though
Yeah, that's where I
they
see
were
them
supposedly the highest quality plants.
Yeah, the RCAs is where I see more of them than anyone
Hmm.
else.
Interesting. Okay.
That's
So,
a good one. I'll be on the lookout for that. One of the fun parts is, I'm the shoemaker. I have the best shoes, but I don't wear them, and I just love touching you guys and being at shows and being able to touch a record that I would love to own, that I've restored, that maybe I've heard just one 4-minute blurb out of it just before and after. But you guys have such the variety and diversity of music that we all love is just amazing, and it's nice to bring that back to life.
Okay. Thank you.
Paul, my co-host, take it away.
Talking about me, Mark?
Yeah.
Yeah, Charles, I want to apologize. I passed out about halfway through the presentation and woke up in time for the raffle, but I did have a question for when I was awake and listening. In today's current record pressing market, how prevalent is it that the large commercial record pressers are using, recycled material? You talked about, a record would come out poorly and they chop it up and throw it back in the bin versus just having a bin full of, I guess, what we could call virgin vinyl or whatever. Is that still an issue these days?
Well, I'll take the first shot on that. When I was over at Cascadia, they recycled theirs. When I was over at Denon, they recycled theirs. Denon in Taiwan. So they recycle with the label. Now we do have people that are running small runs of specific records using plants, and even the producers are kind of making their own mixes and whatever. Everyone thinks that a needle needs to be lubricated, and it doesn't. That's all I have to add on that.
So they're basically trying to save a few pennies during the pressing process, but how much is it affecting the quality of the record we're purchasing?
Well, there are a lot of people that I meet. I get more calls of people complaining about brand new records that they bought right out of box, and returning them. And I'll give you a little snapshot, because there's also something else going on that I think we all need to realize as a community. I was at a trade show, and at the trade show, I'm always in the record fair area, and one of our illustrious members out in Philadelphia, he brought a fellow over into our booth, and he bought a brand new record. And he said, I have one of your systems. I want you to process this record, so my friend maybe purchases one of your systems. So we restore the record, and then we play it, and it's noisy. And I said, well, there's something wrong here. And then we took the record to the light. And again, this has nothing to do with production. This is records being sold at an audiophile event. And there were scratches all over the record. And this was sold as brand new, current pressing. So we all walked over to this vendor, and we showed him the record. He gave us a new one. And we did not even bother doing any processing. We opened the package, and the whole surface area had 4 or 5 nicks on a brand new record. So what's going on? I have a suspicion where we have distributors that are redistributing records that have been returned because someone has played them, has digitized them, or recorded them, and has returned them. Because I cannot fathom brand new records coming out of a pressing plant having the scratches that we saw when we were over at the DC show. And then, of course, I was politely, if you know Gil, who organizes the Capitol Audio Show, one of the guys says, we don't want Charles in here anymore. Well, it's not my fault. I didn't do anything. We opened up a package and we didn't even touch the record and it was scratched. So anyways, buyer beware.
Are there certain reputable manufacturers like RTI or Palas and some of the other ones who are not doing that?
I would expect none of them do that. So that's why I mentioned maybe there's a distributor in the middle taking records back, and you can reseal a record, you know, with the packaging now. Looks brand new.
When I said not doing that, I was referring to just using, you know, vinyl without all the recycling materials from old records.
Oh yeah, no. Well, I don't know about them, but the Denon uses it, and
Right.
Denon has one of the best pressing plants around.
Although sometimes you do see records that claim 100% virgin vinyl, particularly on audiophile pressings. So I assume if they say that, they're not using recycled PVC.
I mean, Murphy used to say that 20 years ago. I don't even think they say it anymore.
Hmm.
They may intimate it, you know, in their marketing materials, but I don't recall any new records that I bought that said, you know, 100%, you know, virgin vinyl is on it. Of course, I could be wrong.
Okay. So Joel, I'm sorry, you've been wanting to ask a question for a long time. Go ahead.
Okay, hear me okay?
Yes.
Yep.
Okay, actually, I've got a few comments that the old timers and the vinyl people will find interesting. Number one, I've never been to one of your meetings. I hope this is not the last one because it was fabulously interesting to me.
Oh, very good. Thank you. So, and where are you, by the way? What audience are you?
Newton, Mass.
Very good.
Oh, cool.
So I had a conflict of schedule, and I'm glad I picked you guys. I had a conflict because exactly the same time there was a Boston Audio Society meeting. So I'm almost surprised that they didn't change, or I hope they'll be able to get a listen to this thing at some point.
Joe, you can watch the meetings on Facebook and also now on YouTube, I believe. He's making recordings, so you can watch them afterwards.
Yes, I'll try to get this posted on YouTube ASAP. It'll be available on Facebook immediately or within a few minutes. And so anybody that wants to join our Facebook group, just look for the Audiophile Society on Facebook and I'll let you in. So I'm sorry, but go ahead, Joel.
All right, some ancient history. Things only go back so far, like me. Summer of 1958, my late electronics audio guru, Vincent Ski, who was at that time in Stamford, Connecticut, Electronic Applications, Inc. He was importer of Revox, Nagra, EMT, things like that. And he took me over to Cook Laboratories, Emery Cook. Who had his, at the time, supposedly exclusive pressing process that he called microfusion. And he produced records in all sorts of wild colors and all sorts of wild subjects, which I still have some of. And that was, anyway, that was one old point, interesting point in the vinyl department. One thing I had a question about is I used to use a record cleaning solution probably about 60 years ago, and I still actually have a little bottle of it, which was put out by Radio Shack. I don't think it was their label, but the stuff seemed to be so what's the word I'm thinking of? Anyway, couldn't have had anything bad in it. It was so weak that I thought I could drink it. I'm not sure it ever did any harm or any coating, but and I've still got some, so maybe I'll be a little bit more attentive the next time around. But yeah, so glad I could be at your meeting.
Thank you. Thanks for joining us.
Well, I did see a related question here. Someone asked about Triton 100 and they said they don't use it anymore. And someone else asked a question about the various different turgitols and whatever. Yeah, again, Triton is made out of the ethylene oxide and the ethers inside. And again, if you take a look at their composition, you know, they create the brittleness and whatever that's being deemed affecting, you know, the PVC itself. So I just wanted to kind of answer that. And again, you know, just like what we had before, I can't comment on what's on the bottle. Read it, go online, PVC chemical compatibility chart, and certainly don't buy anything that has nothing written on the label. And for you, Joel, you know, there's probably an expiration date on that. That's you know, like everything else, it's probably all maybe it's good because all the alcohol's gone out of it. Who knows?
Charles, I just wanted to add one thing. You know, people talk about all these surfactants and having used them in biochemistry over the years. I think one thing that people fail to recognize when they use it in their cleaning solutions is how hard and how many washes it really takes to get these surfactants off the records. Because, and again, it depends upon the surfactant, because I know we would measure it by enzyme activity, and you would do like 5 washes and you might still see that it's inhibiting enzyme action. And so that was one really ultra sensitive way. And, you know, a lot of people won't even do one water rinse, but you might need several water rinses. And if you don't, it affects the sound. That's kind of one of my complaints with using surfactants at all, kind of, unless you properly clean them, you're going to affect the sound.
Yeah, and that's why we go through all these processes in and out, charge the record, loses its charge the record, loses its charge, and so on. And when we're finished with that, the record virtually comes out virtually dry. So there's, you know, using the microfiber cloth, the optician's cloth, just to remove the few droplets of water, the parastatic felt to push it. You don't need any vacuum. You don't need any air drying because we've stripped everything off. That's keeping the water cooled.
Miles brought up rinsing, and I noticed in your video with Michael Fremer where you demonstrate the product, you followed it up with like spraying the record with distilled water.
Yeah, we don't do that. Yeah, we don't do that anymore.
Thank you.
When we first started, we have to put a little.
It's not in the manual, right?
Yeah, it's not in the manual. That's why we say consult the manual. We're going to have a little, you know, little blurb on that. Originally, what was, and this is coming from Mike. He says, Charles, you got leftover solution on your record. So, you know, and we didn't realize that in 2018, the record comes out virtually dry. So there's nothing to remove. So there's no liquid. So we don't have to mist it. So, so that I'm glad you brought that up, Mark. That's great.
Okay. And Bob, I'm going to skip down to you because I know you wanted to make a comment like 10 minutes ago. So I'm going to cut down to you. What were you going to say?
Thank you, Mark. This is Bob Attia from Yarlung Records, and I wanted to comment on the recycling of vinyl. It's what they call regrind. And we have used 2 record pressing plants so far. We've used RTI in Camarillo, and we've used Pallas. At the moment, Pallas is not using any regrind in the vinyl, at least in the pressings that we use. They have not always been perfect, but they're very good. I remember to our RTI days where we got some of our very good vinyl pressings using vinyl from Thailand, actually, that this regrind question came up. And at the time, they were, by the way, punching out all of the labels so that all of the records that they were using for regrind had big holes in the middle. So they were not regrinding any of the paper label, which might give some of us a little bit of reassurance. However, what they found at the time was that a specific percentage of regrind was actually quieter using the Thai vinyl than the 100% virgin. I didn't have a chance to check that myself, but the vinyl that they were pressing with that small percentage of regrind was very quiet. Some of our best pressings came from that. Just a bit of tidbit of information for our vinyl lovers out there.
Yeah, there is always an addition of what we call the stabilizer, the plasticizer, the liquefiers, and all of that comes into play. When you do a regrind, you obviously have the mix is less potent as the original PVC because we've already had that leaching effect. So there's, you know, it's a moving target. It's a moving target. Again, going back to reproduction and, you know, I mentioned, you know, tone arm adjustments and making sure anti-skating, tracking, angle of cantilever, assembly, and so on are correct. I think between both removing release agent and having a properly adjusted tone arm like JR's been also upsetting the whole world as to $20,000 cartridges that have been made by Radio Shack. Not a little humor, not with the proper angles of the cutter. We're, you know, we're trying to get the artist in our mind and our ears and our heart, and those are the two biggest bangs for any dollar out there, I think.
Thank you. And thanks, Bob, for that insight. That was excellent.
Absolutely.
Joel and Brian, I see you guys have your hands up again. Joel, you want to go first?
Further comment on what Charles said, that Radio Shack bottle material cleaner, no sign of alcohol. It had a very mild, maybe musty type aroma, but that's about as far as it went. I still don't know what was in it, but I'll find out. The other thing is on EMT, one of the products that my guru represented and used at least at the 1958 Boston audio show was an EMT studio turntable. You know, it had its own preamp. It had, I think it had a low cut adjustment. It had automatic cueing, and it took up to 16-inch transcription discs, and it was a real monster. But I thought I'd mention it because not too many people have seen that. And it used, as he would put it, it used an Audiophile cartridge and tone arm, which he described. For you old people, tell me if anyone ever heard this one. He described, remember the the Audiophile, the EMT Audiophile cartridges or ESL US cartridges, those were mono days, as rejects from Audiophile.
Yeah.
So I don't know. Mine was pretty good. Anyway, thanks again.
Nice. Thank you. Brian, go ahead.
Yeah. Charles, are you familiar with Neil Anton and his paper on precision aqueous cleaning of vinyl records? And what do you think?
No, I'm not.
Oh, okay.
I'll send you a link because there's, I believe, either a third or a fourth edition that was out in recently. I posted a link to it in the Audiophile Society's Facebook group, but I'll send you a link to it. It's very interesting.
I'd love that, and maybe we can have a session on that.
Yeah, it's extremely technical.
Something popped in my mind when we're dealing with transcripts. We just talked about transcripts. When we're dealing with transcript records, we're dealing with shellac records. They're not manufactured the same way as PVC or polyvinyl records. So just as an FYI, our process is apply this, remove whatever, gray fungus or gray or brown fungus with a wet microfiber cloth in just 5 minutes in the machine, one cycle. That's it. Because they're not made the same. We don't have the same. We don't have plasticizers, stabilizers, release agents that come out of that. They're either shellac coating or they've been actually cut or molded into a substrate. So that's all in the manual. So I just wanted to make that.
All right. And Brian, I probably cut you off before you actually got to your question. Was there something in particular in that paper that you wanted to ask about?
No, it is extremely technical, although he doesn't back it up with a lot of science, but he offers he does talk about ultrasonic machines, but the bulk of the paper is his proposition that you can get a record as clean as an ultrasonic or as clean as it can be with a manual process.
I have read, okay, I've read a statement like that. And like I said, that's totally false because of the ionization of distilled water, the charge of the record, you cannot, and the size of the water, the droplet. Ultrasonics are the only way to be able to get that size into a groove and into a material where you've changed the charge.
Right, and
And we take records that are processed, by different methods with the owner at a trade show, coming down also to our office, and then we measure it. So, just to say that it's the release agent you cannot remove just with a cleaning agent. And you saw from Shure, even using an alcohol, we were not able to remove it.
Yes. And in this paper, by the way, I don't know if he gets into the charge of the water in the record. He does get into the microscopic size and mentions your unit by name and says that because of the application of surfactant, that the cavitation bubbles create a wave that combined with the surfactant will get all the way into the grooves. So part of it is dispelling the myth that a 35K ultrasonic cleaner can't get into the groove because you need to be 100K or whatever. He dispels that myth because he says the surfactant makes all the difference.
Oh, well, yeah, and that's what we mentioned. And I said, you don't use a surfactant on a 45, 60, 125 kilohertz ultrasonic. I mean, our ionizing surfactant, not a cleaner. So I'm very specific when I say ionizing surfactant. We'll sandblast the record.
Yes.
And then you'll be unhappy. There's one manufacturer that went out of the business because too many people said, oh, I have the machine. I don't have to buy Kirmus's at 1/10 of the cost that I paid. I'm going to use a spray. And then all of a sudden we get calls from people that, what did you do to my record? I said, excuse me, your serial number? I said, oh, no. I used this one here with your spray. That's why we got the non-disclaimer on the website. We got it in the manuals.
Don, you ask first, and if Stephen Marsh is still here, you can be next.
Okay, two questions.
Oh,
this
sorry.
is Don. If I'm using my VPI machine and I've got a mixture of distilled water and a little bit of alcohol, and I'm pushing down with the brush, doesn't that break the surface tension enough for the fluid to get into the bottom of the groove?
No, it doesn't, because the fact that you have to take a look at the size of the groove, like I said, we're 40, 45 on the top, 30, 35 in the middle, and 6 microns in the bottom. The size of the water droplet is larger, and you cannot break that water droplet unless you use an ultrasonic. So all you're doing is surface cleaning. Never use alcohol. And then what you're doing on drawing, you're actually leaving a film on the surface of the record, Don.
Okay.
And we can measure that.
Okay. Second question then is,
and that's depending on how dirty the record was and what you did bring out, by the way.
okay.
So I have to qualify that.
Okay. Now, when you talk about the mold release agent, that's part of the compound that the record is made out of. When Peter Goldmark developed the LPs back in the 1940s, he had to balance between elasticity and rigidity. Enough elasticity that when the stylus go through the groove, it doesn't break the groove, it doesn't chip it off, but yet enough rigidity that it maintains its shape. So the mold compound, the mold release that is part of the complex chemical that makes this thing up, that makes up the record, if you extract some of that, are you not making the record a little bit more brittle and therefore susceptible for the stylus to be chipping off little bits and pieces?
No, there's a difference between what we call a plasticizer and what we call a liquefier. And the liquefier, that's part and parcel of that PVC, is what surfaces. The plasticizer is what remains in the record, that obviously an alcohol will make it brittle. It won't break it, but what happens is now you pick up all that high frequency sound that you hear in the background after you've destroyed that plasticizer. And then in that circa, by the way, everyone was working with polychloride, not polyvinyl chloride, but polyethylene/poly records that you saw in one of the slides that I did put a little capture on there, where they actually had waxes included as well as zinc in order to accept the very, very hard steels that were not hard per se in the sense of anything more than damaging the record and gouging it, and using those waxes as a lubricant. So that goes back to that earlier slide.
All right, thanks. Stephen Marsh, go ahead.
Yeah, thank you. You were talking about the goat hair brush, carbon fiber brush, and chargers on the charge on the record. Do you find a zero stat of any use from your perspective?
Yeah, well, here again, I live in very dry Colorado. It's been miserably cold and a little more humid than normal, but records do plastic picks up charge, and the zeostats do work and they do remove the charge. Just as a 2.5 million carbon fiber brush, if it's grounded to your hand, you'll also be able to remove that when you're moving that across your record.
Okay, thank you.
Thanks. And Bob, before I get to you, I have a quick question about the use of the product. How do we clean your microfiber? Both
well,
this
we have
kind
two
of towel and the optical. Are the opticals cleanable, and what's the best way to clean them?
Okay, well, for the optical, just use this, just wash it with distilled water and then just let it air dry. That's it, in an area where you don't have obviously dust. You can do that 2 or 3 times and then it's time to throw away. The bunny cloth that we use for the work area with a picture of Skip on there, toss that into just your washing machine. Don't need soap, just let it go through and the spin dry. And that cloth you'll use either on your work area, but also in new records where we say if the record comes out of the first 5-minute cycle with pools of water, that's a horizontal. That either says you have a protectant on there, or you have a brand new record with all these elixirs they put in there. Then you use the bunny cloth to remove that, add the spray so you don't dilute the 1 or 2% propanediol. Put it in the machine, and that's what you use that for. But yeah, toss it in, not with a regular wash. You don't need anything except just a wash, gentle cycle, and you can put it in the dry, fluff dry.
Right, but keep all your microfiber together and wash it together. Don't mix it with your Levi's, and also if you've got microfiber that you've used on your car, you probably don't want to wash it with the microfiber you use on your records.
Yeah, as a matter of fact, what's interesting is I go to Costco and buy microfiber towels, and they're horrible. They got all sorts of stuff. Our microfiber is the bunny cloth is also lint free, but you treat it just as any microfiber. You don't, you only use the opticians for polishing.
Okay, great. Thank you. Bob, you want to ask? Thanks for joining us today. I know you had some family duties to attend to, but thanks for joining us.
Great, thanks. I just wondered, since Mark knows I'm a retired librarian from the Philadelphia Orchestra, but other people don't know that I had that in my background. And since I retired a couple of years ago, I haven't had any need to speak to any of my colleagues down at Library Congress. And the last time I spoke with Charles at a Capitol Audio Fest, I know he was consulting with them about the long-term care and treatment of their records. So since LC is so often cited for decades and decades of archival work, and I had put a post in the chat room because I have a copy of their 1959 study.
So do I.
Right. So I just wondered if Charles, you could tell the people listening what methodology LC is using, since they are so commonly referred to, and certainly are our national treasure for the archive, and of so many manufactured goods and books, print, so forth. Also, how although not too many of us are collecting 78s and shellacs, but you might want to address that in the response. And I think that's it. Great talk. Thanks. And I just learned something moments ago, that it was no longer necessary to miss the records at the end of the cleaning. I didn't realize that had ended.
Well, thank you, Bob, and welcome. I saw you pop up and whatever. It's nice to have you. For your first question, I plead the Fifth Amendment. I defer that to legal counsel. I don't want to incriminate anyone. No, records are fragile. You know, they are better than, you know, CDs and DVDs and SACDs and hard drives, because once they're damaged, you can't hear them, you can't play them, they're gone. And our brain can assimilate pops and scratches and all sorts of things, and you know, we can appreciate our revival of vinyl for those reasons. And we can touch it, you know, and see it in the beautiful contests of the beautiful printings and so on. I'm very disruptive when it comes to the LOC. We were together next door to each other over at the Capitol Audio Show, and I kept restoring records for them. And they then presented me with the Edison cylinders that they've been trying to play, and they were cracking, which for the ARSC the following year, and for John, I was able to restore. But when it comes to vinyl, I have not seen, or we've not spoken about anything more where they don't recommend Turgitol anymore. And quite frankly speaking, I don't think they're focused on redoing any records that they've already perhaps archived on a digital media. But in dealing with the American Society of Radio Collections, of which they're a major part of, everyone's more interested in tracking the artists and the lineage of that, rather than taking a look at have they harmed their records or what to do with records. And I've had my discussions, and as you know, I am disruptive, and I'm not a conformist, and I work with science. And I'm surprised that whether it be on LPs or whether it be on Edison cylinders, with all the resources they have with chemists and scientists, with educated people, which I am not, it just behooves me on some of the things that I hear. So, you know, I offered, I'd like to come in, I'll bring a microscope down, or we'll have Keyence come down. We'll give you nuts and bolts, use the equipment for a couple of months, do whatever you want, but it didn't go anywhere. So now we're proving that we can restore the Edison cylinders, and we can bring them back to life, where they were applying 30 grams pressure and they were cracking them all.
So, Charles, I have another question. One of the things that came with my record cleaning kit was this stylus cleaner.
Yes.
What is in this? And what do you recommend for cleaning your styli?
Very good. Well, you certainly don't use the little tacky strips that pull down on your needle and affect your cantilever. And that's been a big disruption that J.R. Boisclair discovered.
He got himself into trouble for that, yes. But
yes, he's just as disruptive as I am, where we found deposits that are very hard to remove of the stylus. Long story short, what's in there is the same material that's in our. So here's the blue bottle. You got the clear one. It's 1 to 2% propanediol, 1-2-178 in 98 to 99% distilled water. You take it does not affect from silversmith or ortofon or any of the adhesives used for the diamond mounting and so on. It's neutral, and it also changes the charge of the plastic of the cartridge to repel dust.
So this is not, again, with the deionized thing. This is not
No,
deionized
distilled.
water.
No, it's with distilled water, yeah, and because it has the bipolar surfactant in there, it changes the charge of your charge on the plastic on your cartridge, so to repel dust.
All right.
It's safe.
Very good. Thank you.
Your stylus cleaner, is that available for purchase
Yes, it is.
on its own?
Yes, it is. Yep. $9.
What?
$9 plus shipping. That's correct.
You were the dealers.
Through me, our dealers. Just take a look. Kirmuss, KAN-1. Where are you located?
Jersey.
In Jersey. Probably the closest would be Elusive Disc that would have it online and they ship it over to you.
I will put this up there so that it's in the video. And there you go.
Is that Paul? So you're asking for it?
Yeah.
Yeah, who was that? Okay, Paul, what I'm going to do is I'm going to send you that. I'm not going to charge you for it. And I'm also going to send you a bunny. So that'll take care of you when you're going through all the chemistry that they're giving you and whatever. So I'm going to send you a bunny.
Thank you so much, Charles.
Oh, you're more than welcome. No worries.
Excellent. Paul wins the bunny.
Paul gets it just because he's Paul. I did want to include something. One of the, that you can do all these signal tests and whatever. I mean, one of the things that I did, I visited the folks over at Sweet Vinyl in San Jose. And they're the guys that make the little box that goes between your turntable and into your phono stage amplifier. And they have an algorithm. They use digital technology. I'm going to get hit. I'm the inventor of digital video and audio recording in the electronic security business. Mr. Fremer gets mad. You didn't invent it. Well, I did. But anyways, long story short, I'm not a digital guy. I own no digital stuff here. It's all analog. But I have one of their machines, and I use it also when we started. And you'll see some of these videos now because we did the tests of ultrasonics with foil, what works, what doesn't. We're going to also include, their cleaning. What did they do? They reduced the signal. Did they remove the pops? Well, I use the sugar cube in the pop mode, which allows me to hear and also to count the pops before and after. So that's another validation. And what we're trying to do is we're trying to get a Grammy. We're trying to get an Oscar. We're trying to get into the Record Academy. We got some of musicians that are fans of what we do. We restore 80-year-old records. We just did the 100th anniversary for KDKA and their transcripts where by accident I ran into thousands of transcripts. They're the oldest radio station commercial in North America, celebrating their 100th anniversary in November last year, and we restored their transcripts, which are being digitized. And if we ever get out of COVID, it'll be people can listen. And the $1 million record that I show around, folks, it's was picked out at random, and it was a 1963 rebuttal of the government forcing the removal of public funding for public radio, and that just fell in my hands. So Jim Grazy's the station manager, and we restore transcripts as well, and they were only made to be played 5 times or 6 times before they're gone.
I'm going to thank you, Charles. I'll leave the Zoom going for people that want to BS amongst themselves, but I will stop the recording soon. I really appreciate what you've done, and I appreciate all the work you put into this presentation. It was fascinating, thorough, and I know a lot of people have sent me messages already thanking me for this, so we really appreciate it.
Well, again, I'm very grateful for not only your audio society, but also have Mike and Bob over at the LA Society, and then it's gone to Australia, gone over to Europe. And what I'm just trying to do is for us, because we're all conservators of records. The studios are gone, the pressing plants are gone, the the master board guys are gone. You know, some of the artists, you know, Miles Davis, he got the worst plastic in the world when he started. Those first records that he's made are removing the cheap release age, well, removing whatever comes out of his old first records because he wasn't given the best PVC. We bring his records to life. It's a lot of fun. And then when you meet people that are collectors of his, telling you, boy, you know, the rubber meets the road. It's a lot of fun.
So many of us are getting back into vinyl. I mean, I was the digital guy. I even did an article in Audio Magazine with Steve Guttenberg, and he was the LP guy and I was the digital guy, and we were sort of making fun of each other. And I've come back to records myself. I enjoyed them tremendously, and it used to be that that wasn't the case. I felt like, oh, I put on my digital and I don't know, it sounds better than my records, so what's the point? I don't find that to be the case anymore. I put on LPs, and more often than not, I think they probably sound better than the high-res remasters that are available. So we're all getting back to LPs amazingly, and I think the interest in this meeting is a testament to that.
Well, we had 4 pages all full, so we had 200 people up at once.
Wow.
And that's amazing. And you know, my wife said, so this has taken 3 days of work. It took a half a day of testing. It took a day and a half of building these. And I didn't cover all the other processes and whatever. I was saying just on ultrasonics. And I think the stock of Reynolds aluminum has gone up, and Alcan in Canada. And the hobby store said, boy, you're buying so much balsa wood. But it's also been hard to figure this out, because in one of the machines that I put this in, it was violent. I had to remove the flippers. I had to remove 2 rubbers. Because that thing would just spin around in the drying cycle, and I was more interested in the what they call the cleaning cycle. So it was a lot of fun, and I enjoy it though, because I learned from all of you the questions, and again, to see Bob come in, and that's an honor.
Okay, well, thank you so much, and I'm gonna.
Yeah, and I'll be online. I mean, we can all sit and enjoy.
Right.
I wish I can share a bottle of wine with you guys.
I'm going to
virtually,
go.
maybe
I'm going to go open one very soon.
Well, in closing, we have at the Radio Club of America, by the way, please join. We're the oldest electronic society in the world. We encourage youth. I'm part of the youth committee. I'm a past chair. I'm a fellow. And we want to bring young kids through ham radio, into electronics, into astronomy, into meteorology. Please join us. We have free speakers. The inventor of 5G already gave us 2 years ago what 6G is about. I've done stuff on tubes and whatever. Please join. It's a passion, and it's spread the word. And again, vinyl rules in my books.
Yep. Thanks so much. And I'm going to keep the Zoom on. I'm going to go get a drink, except, you think I've been drinking coffee or tea, but I'm just faking it. That was beer in there.
Yeah, and thank you for all the little pop-ups of the thank yous and whatever. And I'm here to answer questions. Just unmute you. Can they unmute themselves,
Yes.
Mark?
So
okay, good. Unmute yourself, and we'll stay online. Talk about music. Talk about anything. You guys can talk to each other as well. This is your society, so let's just have a great time for those that want to chit chat. And Don had that beautiful record. He showed up. That was great. And Brian brought up some great points. And I love Joel going back to the 50s and whatever, and Radio Shack, and Barry. I see Ross there. I mean, a lot of faces. I'm really honored that you invited me, Mark.